Uh, should do it in announcements or where? Because I can't see it. The link to YouTube. Are you not interested?
Okay, I'm just gonna go ahead and start since it's 3:10. Okay, so first of all, hi guys, my name is Hirsch, and I'm an officer in the Google DSC Club. And today I'll be teaching a workshop on Python, and we plan to make it a 3-part workshop. So, in the end game of in the last workshop, we will be teaching you how to make the game Snake. So we'll just slowly build up to that, and today we'll be going over like basics of Python and introduction to object-oriented programming. So we'll go over some basic operations and data types. Okay, so some good things to know first of all is that you can actually make comments in Python. So I'm not sure if you guys are familiar with C++, but in C++ it's two forward slashes, and in Python it's just a hash sign or the number symbol. So like as we can see right here, it says hashtag, and then this is a comment, hashtag print will print whatever is in parentheses. So that's how you can make comments. Another way of making comments or multi-line comments are using docstrings. So you could make 3 quotations or 3 even single quotes, and whatever you write between those quotes will be commented. Meaning that when you run your code, the compiler won't actually compile or run that code. It's just there for you to make notes or like document things. And okay, a very important function in Python is the print function. Just like Java has console log or system.out.println, or JavaScript has console log, and C++ has standard cout, in Python it's print. It's very standard. And whatever you just write in print will be printed. So as we can see here, it's just a basic hello word, print hello world, and in the output it says hello world. And input is a function just similar in C++ how there's cin. In Python you could just write input. So here we have a variable called name, and then I just wrote input, what is your name? So whatever you put inside of the input, like inside the parentheses, that's what will be outputted. You don't actually have to make you don't actually have to print something and then write name equals input. You could just write name equals input, and inside the input function you could write whatever you want to display. And whatever you write after in the console, like as you can see here, it says it prints out what is your name. I wrote Hirsch, and then now name actually equals Hirsch, leading us to the next part, which is f strings. And it's basically another way of printing. It's actually called formatted printing, so you can insert anything inside the f string. So here it says you can insert a variable into a string using f strings. The syntax is simple, just insert the variable in between a set of curly braces. So here, all we have to write is print, and to make it an f string, we just have to indicate f before the quotation. So, you know in other languages how you can have to write like cout, and then you write something in quotes, then you do two greater than or 2 less than symbols, and then you write like let's say a variable, and then you have to write 2 more less than symbols and write something again. Here in Python, you don't have to do any of that. You could just write hello, put 2 brackets, and then write the variable name, and it will print it. It will just print whatever is the output of the variable. So let's actually just code this up real quick. So it's just a simple hello world. And also you guys can all follow along on Replit. So you guys can just open Replit and make a new Replit, a Python file. And let me just show you guys how to do that. So you can click create, Python, and then, I'll just make a new one. Let's call it hi series 1. And we can create REPL. Also, let me know if I'm going too fast, if you guys have any questions along the way, and I'll be sure to answer them. So let's just code up a simple hello world since it's our first Python program. So here we can just write print, and then hello world. And we click run. And we see it says hello world, right? Now, let's just make a quick comment, just to get how comments work. So we use a hashtag, and then print hello world using f-strings. So let's take some input. So let's ask for someone's name. We could say name equals input. And we can ask the user, what is your name? And then we can print f hello name. And no, it stands for format. So actually this thing is in C++ as well and in C. And this is actually one of my favorite ways of printing things because it's very convenient. So it stands, F is for F string, as we can see here. F is for F string. And it's another name for this is actually called formatted printing. So here you could there's actually a lot of things you could do with this. I'm only going over the briefs of like, you could input variables into this without having to click like plus or have multiple print statements. So you could just do everything in one. So it's easier. But there's a lot more things you can do, like formatting how many decimal places you want a specific number or float to be. And there's a lot of customization in f-strings. And f-strings just stands for formatted strings. So it's not necessarily float, it's just format. So here we're formatting this string to have the variable name inside of this entire string right here. So when we click run, it says, hello, what is your name? We can type Hirsch, and it says, hello, Hirsch. Yeah,
Can you
so,
do it without the F?
excuse me?
Can you do that without the F? Like, is there a way to
No.
do it? Oh, okay.
No. Yeah, you need the F. Because the
Alright.
F tells the compiler that it's for formatting. Alright, and then let's go over a few data types. So these are like the big four primitive data types in Python, and in Python you don't really need to tell a variable or indicate that a variable is of a specific type. Because what's actually happening in Python here is that when you're assigning this number, integer, or float to this variable, the variable is thinking of it as an object. So Python is actually built off of the language C++, and in C++ everything works on classes. So as we can see here in this example, I've assigned a few variables with some different values. This one is just 314, this one is 3.14, this one is obviously a string, and this one is a true or false value. So what Python does is it automatically treats this variable as an integer, this one as a float, this one as a string, and this one as a boolean. So integers are whole numbers, string is just a string of characters and it should be surrounded by double quotes. Floating point numbers are numbers with decimal places, and then when you do a calculation that results in a fraction, like 4 divided by 3, the result will always be a floating point number, if you have it as a floating point number. And booleans are conditional, so true or false. And one more thing, I actually forgot to write it right here. It should be in the next slide actually. But there's something known as typecasting. And you can convert a variable from one data type to another. So let's say I want to convert float to an integer. I can write, or if I want to verify that it's actually, okay, let's say in this example, we have height string and we wrote it as a string, right? Because we see that there's double quotes and it's 12. That means this height string is a string of 2 characters, 1 and 2. However, if we want to do addition with it, right? We can't say that the string of 12 plus an integer of 13 is going to give us 25, right? Because that would give us just a string plus the number, which would just give us 1213. However, if we want to do that, we can literally convert it to an integer just by writing integer in front of it, int, and putting 2 brackets. Similarly, we can do the same thing with floats and strings. And to verify what data type we actually have, there's a function called type. And if you see in this example, I've printed out the types of each of these variables just to verify. So right here we have n, and we're calling type of n, and we can see n is just a whole number, right? And the output is n is of type class int. Class int is coming from C++, as Python is built off of C++. So it's just telling us that this variable is of the data type integer. And as we can see for the other ones, 3.14 is a float, S is a string, Google DSC club, and B is a boolean. So let's actually try using the type function real quick. So let's just delete this. And then we can say, we can create a variable, let's call it num. Num equals 4.32, for example. And then we can print f, and then num is of type num. And when we print it, it tells us that num is of type float. And right here, we're just verifying for this example, like as we can see after we've converted 12 from a string, because right here 12 is a string, we've converted it to an integer, and when we print out the result, we just find out that after we converted it, it's now actually an integer. And yeah, someone had a question? It depends on what exactly is the decimal place, because Python actually uses basic math rounding, and we'll be covering that actually a little later in this presentation. Yeah. So let's go over a few mathematical operations. So we have addition, subtraction, division, multiplication, and modulus. So add, subtract, divide, multiply, they're pretty self-explanatory, right? You just add two numbers, subtract two numbers, or add the left and the right, subtract from the left what is on the right, divide from the left what is on the right, and multiply the left and the right. Modulus operator, which is a percent sign, is otherwise known as a remainder operator. So if we do something like 8 mod 3, we would get the value of 2, because 8 divided by 3 is actually 6, or 3 goes into 8 2 times and there's a remainder of 2, right? Because 3 times 2 is 6 and 8 minus 6 is 2. And a very convenient operation in Python that you can't really do in C++ or Java is the exponent. You would have to, in the other languages, you'd have to include a math library and then actually call the power function. But here, you could just do it. I actually didn't include this in the example, so we can just code it up real quick. So here we can see if we have num, let's say num1. Num1 equals 3, and then num2, let's make it interesting, let's make it a float. Let's make this a 4, and then let's make this a 0.5. So then, if we print num1 to the exponent of num2, oh, this is 0.4, oops. We get 2.0, so 4 to the 1/2 power, or the square root of 4 is just 2, right? So this is very convenient, and this is one reason why Python is super used in data science. Another very useful operator is the plus equals operator. So plus equals basically says that, let's say right here we have num1, which is 3, and num2, which is 8. If we say num1 plus equals num2, that says that num1 equals num1 plus num2. So it's a very convenient way to modify a variable, and it takes the existing value inside the variable and adds to it. You can also use any of the other mathematical operations like minus equals, percent, or times equals, divide equals, or anything. and it's just super convenient. So like, let's say we have let's say we're running like a coffee machine or something, and there's money inside of the coffee machine. So let's say we have a variable called money, and we could call it 5, right? Every time someone gives us money to buy coffee, we can say money plus equals 5. So what this is actually saying is that money equals money plus 5. So then if we print money, we should have the value 10, right? Because 5 plus 5 is 10. And there it is, 10. Similarly, we could also do minus equals, should give us 0, or even times equals. Yep. So now that we've covered over some few mathematical operations, let's cover some functions. So in Python, it's actually very easy to create functions. All you have to write is define, or def, and then the function name, some parentheses, and then a colon. In Python, the colon is very important. Oh, and one thing I forgot to note is that Python is completely space-based. Other languages might use curly braces, however, Python doesn't have any of that. So whatever is depending on the spacing, that is what determines what is actually inside a certain scope. So right here, we can see that all of these are one tab off from define, right? That means everything that is written here is part of the function define. So in Python, the way to determine how much space you need, it's actually a huge debate in Silicon Valley of what is the right way to do it, but you could either do one tab or you could click the spacebar 4 times. So one tab or 4 spaces is how to determine the correct spacing. So creating functions, this is some basic syntax for a function in Python. It allows you to give a set of instructions a name, so you can trigger it multiple times without having to rewrite or copy paste it. So whenever you have to reuse a lot of code, let's say for example let's say the coffee machine again. When you want to pour different types of coffee, right? Let's say you want to make like a latte or a frap or anything else, every time they still have to dispense the coffee, correct? They just have to dispense a different type. So each function to dispense a certain type could have a small line of code that selects the type, and the rest of the code would be the same for each and every one, right? To just pour out the coffee. So you could theoretically create a function called pour coffee and just call it over and over again, so that way you don't have to rewrite all those lines of code. Anything that is reusable, you can make it a function, just for readability and simplicity. And calling functions. Once you've defined this function, my function, you can just type my function with the 2 parentheses, and it should call it. So let's actually just write this as an example real quick. So let's say define, we'll call it like intro. And we have our colon, we click enter. Do you see how it automatically put us right here? However, in another language like C++, you'd have to do something like this. And then you'd have to type inside the braces. But in Python, we just need to have our colon and have everything at the right spacing. So you could write define intro. Let's have a function to actually print hello world. However, we can ask the user for some input. So we could say name equals input, what is your name? And we can print f hello name. Now we have a function here that is asking for someone's name and it's going to print hello and whatever their name is. But how do we actually use that function? So a way of using this is we can literally just call intro and write parentheses. And when we run it, it should ask us, what is your name? And it gives us the output, hello Hirsch. However, this is just a very basic function. There's many more things you can actually do with functions, which I'll be going over right now. So you can actually pass in arguments into a function. Let's say when you want to call a function, you want to actually input certain values and have the function do something with those certain values. So as we can see in this example right here, we have a function called, oh, this is the wrong slide. Yeah, so this was calling functions, and let's go over inputs first. So when we add two inputs, like as I just said, if you want to have a function take in some values and do something with those values, right? We can have a function called add right here, for example. It will take in two variables and it will print out the output of those two variables. So if we were to code this, we could say, let's create a function called add, and it could take in two variables right here, n1 and n2. And all this function will do, it will just print the result of n1 plus n2. So how can we call this? We know how to call a function, right? We just have to write the function name with two parentheses. However, this function actually requires two inputs, right? As we've indicated right here. So what we would have to do is, let's say we have two numbers, num1 equals 2, num2 equals 8. We would have to add num1 and num2. These are also known as parameters. And parameters is just another word for input. So now, when we run this, it asks us first of all, what is your name? And then it gives us the addition of 2 plus 8, right? Because that's what our function does. And now that we've called functions with inputs, we can do functions with outputs. So you can also have an output, and in order to have an output, you have to precede whatever you're trying to output with the word return. So return is a very important keyword. And you also cannot call any variables by the name of return, since it's a keyword specific in Python. So as we can see right here, in the add function, instead of printing it, it just returns it. So now that this function returns it, whenever you call this function is replaced with the addition of these two numbers. So right here we have add 2 and 3. So when you add 2 and 3, you get 5. So this whole left part or right part just equals 5. And now 5 is assigned to the variable result. And we can just try that real quick. I'll just delete this. So we're going to make something called subtract. n1 n2 colon, and let's do n1, can return it first, n1 minus n2. So when we call subtract, let's make a variable called result equals so num1 minus num2 should give us the value of -6. So when we run this, I didn't even do anything with it. Print result. Yep, we got the value -6. Okay, moving on. So something very important in functions is actually variable scope, and this isn't important in functions itself, but it's important in programming as a whole. you typically have two keywords to indicate scope, global and local. So right here, the variable n equals 2 would be a global variable because it could be used anywhere in the program. However, the variable n equals 3, this n is specifically local to my function. This n has nothing to do with this n because it's inside of my function. So if I print n, this print will net me 2. If I print n, it will net me 2, yes, because 2, I'm printing the value in this variable n. However, if I call my function has a print statement inside of it, which will print the value of this variable. And since this variable has the value 3, it prints 3. Similarly, if we have, say we have a variable called money, and money equals 5, and we create a function called, let's just call it function. And we have another variable called balance. We can see, and let's say balance equals 0. And we can just do balance plus equals money. And then we can print balance. And when we call this function right here, it should print out the value 5, right? However, what happens if we try to just print out the value of balance? What happens if we just try to print balance? As you can see, we're already getting an error. And it says that balance is an undefined name. That's because balance can only be used inside of this function, but it cannot be used outside of this function. However, since money is a global variable, it could be used anywhere in the program. It could be used, we could print out the value of money right here. We could use money inside of this function, or we could use money anywhere. And let's go over some keyword arguments. When calling a function, you can provide a keyword argument or simply just the value. So this is specifically talking about the parameters. So right here, how we said that define divide, and inside divide we pass in two parameters, n1 and n2, and divide basically returns this result of n1 divided by n2. However, to call this function, we can do it two ways. We can pass in 10 and 5. If we do it this way, then 10 automatically gets assigned to n1 and 5 gets assigned to n2. However, if we want to assign a specific value to a specific variable without caring about the order, we can say n2 equals 5 and n1 equals 10. This way, whatever is on the left side will automatically be assigned to n1, but we're directly telling the compiler that we want n2 to be 5 and n1 to be 10. So let's go over some control structures and conditionals and loops. So something very basic is the if, else, and elif. It's exactly what it sounds like. If something is the case, then you want to do this. Else, do that. So, right here we said that this is basic syntax to test if a condition is true. If so, the indented code will be executed. If not, it will be skipped. So right here we have the variable age. Age equals 18. And if age is greater than 16, we will print can drive. Oh, just a note, when using if, else, and elif, we must also use the colon after whatever our condition is. And else, if age, what this else says is that if age is not greater than 16, then print don't drive. And what the elif function does is, it basically stands for else if. So it will only execute if the condition is true. However, when just using an else, the else condition will execute if all the if conditions before it did not. So right here, if we were to say that age is equal to 12, the else would automatically print. However, if this was an else if, and it said like if age was less than 10 or something, then it wouldn't print because it wouldn't follow the condition. So right here we have an example using else if, and we have a variable called weather, and we're saying that weather is equal to sunny. So if the weather is equal to rain, we will print bring an umbrella. Else if the weather is equal to sunny, print bring sunglasses. Else if weather is equal to snow, print bring gloves. So if we were to trace this program, what would happen is it would first go to this if block. It would check if weather is equal to rain. However, it's equal to sunny, correct? So this condition is false. And since it's false, it would go to the next else if. It checks the elif, weather is equal to sunny, and since this one is true, sunny equals sunny, it will just print bring sunglasses and it will not even check this. Another thing to note is that if you have a let's actually just code this part. Weather equals did I spell it wrong? No, I spelled it correct. If weather equals rain, print bring oops. Elif weather equals snow, bring gloves. And then elif print and lastly we can just have an else here. Else print go code, because why not? Why is there an error? Undefined name weather. Did I spell it wrong? Interesting. Weather. Weath. Okay, let me change the name. Oh, right here. Oh, right here. Yeah, there it is. Okay, now it should work. Sorry. Yeah, so what's happening here is that it's first checking the value sunny, which is assigned to the variable weather. It says it checks if weather is equal to rain. It does not equal to rain, so now we will check snow. Does not equal to snow, now we will check sunny. It does equal to sunny, so we print sunglasses. However, if we say weather is equal to, let's say nothing, when we run it, it should print go code. Because when all of these conditions default to false, it will just print whatever is the else statement. So else is kind of like the last resort. If everything before it is false, then it will print whatever is in the else. And we also have some conditionals called and or not. So in other languages, I know that and or are indicated by ampersands or the straight lines, the two straight lines. However, in Python, you can quite literally just like write and or, which is why Python is so readable. So the and only executes if both conditions on either side of the statement are to be true. The OR will execute if either one are true, and the NOT will basically flip the original result of the condition. So if you have a variable of type boolean called like status, and status is equal to true, if you say not status, status is now equal to false. Or it won't set it to false, but it will treat that block as false. So let's just code it up. Let's have two numbers. Okay, yeah, two numbers. Num1 equals 5. Num2 equals 4. So let's say if num1 and num2 equal 5, then we can print both numbers are 5. Obviously, this one has to be false, right? Because we have 5 and 4. So this condition shouldn't even print. Else, we can elif num1 or num2 equals 5. Print one of the numbers are 5. So if we print this, it prints out one of the numbers are 5. And as you guys can see, that Python is super readable, so a lot of syntax in Python can easily be searched up and just learned very quickly. And let's check out the not. So if we say if not num1 and num2 equals 5, so now since this statement defaults to false, if we say not, it should go true. So it should print the first one. Wait. Yeah. Yup, so it says both numbers are 5. So that's how we use the not and an or. And some more operators that we have in Python are these comparison operators. Greater than, less than, greater than or equal to, less than or equal to, equals, and not equals. These are very self-explanatory. So the greater than or equal to just checks if returns true if what is on the left side is greater than on the right side. Vice versa for the less than or equal to. Same thing for the less than or equal to. If the left side is greater than or equal to what is on the right side, it will return true. If not, it will return false. Equals checks if two values are the same. However, keep in mind that this is different from a regular equal sign. If you have one equal sign, it's an assignment operator, and you're assigning whatever is on the right side to on the left side. However, if you have two equal signs, then you are comparing two values, and you're checking if they are the same value or not. Exclamation point equal is negation equal, so it means that whatever is on the left is not equal to on the right. It's just another way of using the not keyword. So let's go over some loops. So we have two main types of loops that we'll be going over today. One is called a while loop and the other is called a for loop. The syntax for loops in Python are slightly different from in C++ and Java, because in Python the for loop it's essentially doing the same thing. However, you're just writing in a different way. So let's cover the while loop first. In the while loop, it will keep repeating whatever is indented inside the while loop until whatever condition you have at the top becomes false. So right here, well, n is less than or equal to 100, n plus equals 1. So this will keep going until n is equal to 99, and then since n is equal to 99 here, it will run again, and now n is equal to 100. It says that checks if n is less than 100. However, no, n is not less than 100, so it will terminate the while loop and go whatever's after it. So we can actually just try this out real quick. So let's say we have a variable n, we could set equal to 1. And then we could say while n is less than 100, n plus plus. And then print n. Or we could say, let's say plus equals to 1. And we can run it. So we can see that n is equal to 100. And another type of loop we have in in Python is the for loop. And the for loop lets you basically iterate through any type of control structure. So I'll be actually going over this data structure later. It's called a list, but right now all you need to know is that it's similar to an array, or you can think of it as a container, as if you're adding items or variables or any types of values inside of this container. And keep in mind, in a list, not all the variables or all the items have to be of the same data type. So in C++ specifically, if you have an array, which is a container, you can only have it of a specific data type. If you write an array of type integers, you can only put integer numbers inside of that array. However, in Python, that is not the case. You could put anything inside of this list. It could be an integer, a float, a string, even a Boolean value, even an object from another class. And let's just go over this for loop. So what this for loop does is that in each value, it will iterate through this entire list and print out each index of this list. So it just gives you more control than a while loop, and it goes over any type of structure. So this specific type of for loop is very useful when it comes to using specific data structures, such as lists, dictionaries, or tuples. However, today we'll only be going over some lists. The for loop that you have probably seen in your computer science classes here are called a in-range for loop. And it's actually another name for this is called a range-based for loop. And if the value for your loop is iterating through, like the number inside of this range, it will do something 100 times. However, keep in mind you can provide more parameters inside this for loop. So let me just show you with some code. And also one more thing, whatever you write after the for, it could be anything. So as we see right here, it says for fruit and all fruits. You could call this whatever you like. It does not matter. So right here, we could just say for x in range 100 print x. So what will this do? It will print each value of x. As we can see, 0 all the way to 99. So what does this tell us? The range function actually takes this, it goes from the start to the end. However, it does not actually utilize the value at the end. So the start value is included, but not the end value. However, there's two more parameters that you could even do. Right now, we've only included one, right? And that gives us the end of how many times we want to do it. However, what if we want to include where to start? We could say start, comma, 100. This will tell us where to start and where to end. So if we start it now, we see it starts at 5 and goes all the way to 99. However, we could take this a step further. Let's say we only want to print the multiples of 5, right? We could iterate this with a step of 5. So right here, we can see that if we hover over the range, it tells us what exactly the parameters are. It tells us there's a start, a stop, and a step. So the step basically says that instead of going 5, 6, 7, 8, 9, you'll take only every fifth value. So if we print it now, we see we get 5, 10, 15, 20, 25, 30, all the way to 95, because it's just printing out all the numbers of all the multiples of 5. However, it will not include 100. So that's why 100 is not there, because it includes the starting but does not include the ending. And as Kenta said in the chat, yeah, that's the lower bound. Oh, sorry, I just saw this question. Start it from a negative number? I believe you should be able to. Let's say negative 10. Yep. And one more cool thing you can do with this is that you can even iterate downwards. So let's say if you say negative 5. Wait, what?
You have to flip your bounds.
Oh, yeah. 100 and then 10. We can even iterate it downward. Yep. So that's just one way to use the range-based for loop. And in C++, if you guys are familiar with that language, it would look something like this. For I or int equals 0, and then you'd have I is less than 5 or something, and then you'd have like plus plus I. However, here, whatever these are, we're just replacing this as our start. This would be our end, and this would be our step. So we could just write it like range 0, 5, 1 if you want to iterate through 1. And we'd have it for I in range. And that's just another example to show how it's actually done. So a continuation of loops is that there's a few keywords which are very important. Break, continue. And what break allows you to do is it allows you to break free of the loop. You could use it in a for or while loop. So right here, let's say we have a list called scores. The scores list has values 34, 67, 99, and 105, right? So for s in scores, if s is greater than 100, we should print invalid and we should break it. So right here, this function right here should only print the values 34, 67, 99, and it will not print 105. Instead, it will print invalid. Otherwise, if s is less than 100, it should print out the value of s. And this actually just breaks you completely out of the for loop, so it will not go through any other iterations of the for loop. However, the continue keyword allows you to skip the current iteration and still continue on with the loop. So the difference between break and continue is that although they both skip the iteration, break just completely takes you out of the loop, whereas continue still continues on with the loop. And infinite loops, sometimes the condition you are checking to see if the loop should continue, and if that condition never becomes false, the loop will just keep on running, right? So you have to be very careful when you code to make sure that you have a way to end your loop, so that way it's just not infinitely running, because that could possibly crash your program. So right here we can see while 5 is greater than 1, right? Print I'm a survivor, but 5 is always greater than 1. This condition will never execute false. A way to fix this would be you could make a variable called num and set it equal to 5, and after each iteration you could say like num minus equals 1. So you could decrement it by 1 each and every time so it can actually break out of the loop. Yes, Kenta. So in Python you actually don't really need parentheses for any of the conditions. It just depends, like, you have to be careful though, like as you saw earlier how I missed the parentheses with the not. Because it will say, if you say not like the first one, it would have just said that variable, it would flip the negation sign for that and not the other ones. So yes, you can use parentheses to be very specific, however it's not needed. So let's just code like a mini example project to tie up all the concepts that we've learned so far. It's like a console calculator. So what are the components of a calculator? You need to find a way to entry numbers correct. You need to find a way to handle the operations. And you also need to output the answers. So let's go ahead and code that. So I will make a calculator in this file only. I've also linked it in the presentation at the very end if you want to see the sample code. However, it would be better if you guys follow along. So what's the first step? What are the components? We can first of all we can just print out, like, let's say welcome to the calculator app, and then we can have we can ask the user for two numbers, correct? So we could say num1 equals, how do we take input again? We use the input keyword. Input, please enter a number, or please enter number 1, and then we could have num2, which would be please enter number 2. However, when coding things like this, you have to be very careful, because what if the user inputs a string? Well, that wouldn't be a number, right? And our calculator only works with numbers, correct? So what we can do is that we can typecast this to integer. So say int, and then int again. So whatever is being inputted is automatically becoming typecasted to an integer. And we can just write some instructions here. Please enter two numbers. And next, we want to know if user should be able to add, multiply, divide, subtract, exponentiate. So we can just let's call it operation. Input. Please enter whether you would like to add, divide, subtract, multiply, divide, or exponentiate. And what type of data type do we want this to be? We don't want it to be a number, right? So what we can do is we can typecast this to string. And one more thing that we have to be careful of is that what if they enter subtract in full caps or add in like capital A, lowercase d, capital D? When we check our conditions, they wouldn't equal to each other, right? So we can use the string function called lower. Since this is already a string, because we typecasted it to a string, we can add .lower to it, and what this function does is it sets all the characters to lowercase. Now, how exactly can we do all of these operations? First of all, we can create some functions, correct? So let's define a function called add, and let's have it take two numbers, n1 and 2. And what it can do, why do we use lower? We use lower to change all the characters inside of the string to lowercase. For example, what would happen if what happens if when we ask this to the user and the user entered multiply, however with the capital M? Do you think this condition would still stay true if we said check if operation equals multiply? This would result to false, correct? Because if the user entered it with the capital M, it's not the same string because Python is case sensitive. However, they still intended to multiply, right? Yes, well, we will be doing the inputs with like plus minus. However, since it's a calculator, we have to check what exactly they want to do. So we will get to that. First, let's just code all the functions real quick. So the addition will just print out the addition of n1 and n2. We can just copy paste this. And let's change this to subtract. Change this to minus sign. Multiply. Or let's just call it mult for short. N1 times N2. Oh. Let's change this to divide. Div. And then let's have one to do exponents. So let's call it power. So now that we've coded some functions to actually do things, we actually have to apply these. So how do we check what the user wants? First of all, we have a variable called operation, and it's holding whatever they want to do. So we can have an if statement that says if operation equals add, then we will add num1 and num2. Elif operation equals subtract, then we should subtract num1 and num2. And we will do the same thing for a few more operations. So one for multiply, one for divide, one for exponents. So we can just change this to multiply, divide, and then exponentiate. And then right here we'll change this to mult, div, and power. However, we also have to consider the case that the user doesn't enter any of these. What if they enter like what if they enter their name by mistake? Hence, we're gonna have an else statement to cover that as well. Else we can print did not enter a valid operation. And what we can do is we can actually make all this into a while loop so that it can just repeat until they do enter the right operation. So what I'll do is I will indent all of this by 1, so it's inside the while loop. Oops. And we'll have let's say we have a status. Status equals true. And we could say while status, it should run this loop. So by the end of this, it would just, if they do not enter a valid operation, it'll just restart. However, we also have to close out of this calculator, right? If you do any of these operations. So what we can say is status equals false. And we can just put this under each one. Or better yet, we could just use the break keyword. Break. So if we run this, we would still need the status. So we can enter two numbers. Let's say 1 and 2. Let's say we want to add. I'm going to add up the two numbers, and now it's exited out of the loop. And one more thing we can do right here is outside of this while loop, we're done, we could print. Please click run to use calculator again. So if you run it again, let's say 3 and 2. However, this time we want to exponentiate, right? But let's say we spell it wrong. Let's say we type in power instead of exponent. Please, you did not enter a valid operation. Please enter whether you would like to add, subtract, multiply, divide, or exponentiate. So this time we can say exponentiate. And one more thing, we can see that if we type it in even in caps lock, add, it will still work because of the lower function. And just for readability, we can say we just make it like this. So yeah, that's how you code a basic console calculator in Python. So we can take like a 15-minute break, and if anyone has any questions, I can answer them right now. And if no one has any questions, that's okay too. We can just take a break for around 15 minutes. Oh yeah, also one more thing, I can just copy paste this calculator into this chat. And then if anyone wants to play around with it, you guys can use this link. Oh yeah, and as Kenta said, please feel free to share your own version of the calculator in the side projects channel. And I believe that should be under general. So we'll re-begin the workshop at 4:16. Oh, you mean like inputting multiple lines into... Oh, doing like multiple inputs in one? Actually, I can search it up. I'm a bit rusty, but let me see.
Like, I'm only asking because, like, I think all the previous examples of getting input was, like, you had to print something first. But Yeah, is there any way like for me to print a statement and then have like 3 inputs where it would take the first word you put, second word you put in the second variable, and the third word you put in the third variable?
Actually, there is a way, but you would have to use a list. So
Oh,
I can show you. I can show you right now. So let me create a new REPL. Python, and then so let's say you have two variables, x comma y, and then you could say equals input. Let's just say like enter two values, and then give a space. And then what you would have to do is, actually I think this should work. If I run, two, no, it does not work. Okay, so then what you would have to do is you would have to use something called split separation, and it's basically it's a separator method. So what that would look like is input dot split, and it's a little complicated because you would have to create your own iterator class. Do you know what an iterator is?
yeah.
Yeah, so you'd have to define your own iterator, and then you'd have to pass it in right here. And what this would do is that, like, let's say you have an iterator. I haven't defined one, but if you have one, and then you have a max for the iterator, and what this would do is it would take all the values and then dump it into a list. So then how you could access those values is you would have to do like for like I in like, let's say you have a list right here. Like, let's say you have list equals like that, and then this iterator class, this iterator object would have to be particularly for this list, and you would have to define that yourself. So when you do it, you could access it like this, like if you say for I in list, and then like you could just print it. Well, this won't run right now because I haven't defined the iterator, but this is theoretically one way you could do it. It's a lot more complicated than like just typing out like if you just do like one print, you can say like print enter two numbers, and then another thing you could do is you could like, let's say num1 equals input. You don't even have to put a prompt, and then num2 equals input. So then when you run it, and let's just print out the two values after. Num1, or let's say it this way. Num1 is num1, and num2 is num2. Say please enter two numbers, and then let's say we do 1, enter, 2, enter. Num1 is 1 and num2 is 2. Obviously it's not the cleanest way, but it is an easier way than using iterators. But yeah, if you would like to do everything in one line, you would have to create an iterator and use the dot split method.
Okay, yeah. Yeah, I was looking at the sub sign, they were using the split thing too. I'll look into
Yeah.
it.
Yeah. So does anyone have any other questions, or can I continue with the workshop? I see that Emmy is typing. Okay, if there's no other questions, then I'll just continue with the workshop. And oh, does num1 equal integer input please enter number 1. Allow me to do 2-digit numbers or just 1 digit. Well, it doesn't matter how many digits you have. Are you talking about decimals?
Decimals, or if I wanted to do like 25 or like 100.
Oh yeah, you could input anything. Here, like let's say we run it again. Or let's say we even typecast this. Let's say to int, right? Let's say we typecast this to integer, both of these. Stop, run. Let's say we enter 25 here, and then 2 for the second one. 25 and 2. However, let's say we try entering 2.5. It will give us an error because it's typecasted to float. But yes, there is no limit on how many digits you have. But you cannot enter a float or any other type of syntax because there's you're typecasting to integer. So if you're actually using this for like proper programming, you would want to do something like throw an exception error or something so it doesn't just break the file right there. However, it throws an error saying that you didn't enter the right data type or something along those lines.
Thank you.
I see that Gobind also has a question. Okay, well then I will just continue with the okay. Never mind. List equals input your name dot split. Yes. So yes, what Gobind said, that's another way of doing it. It'll automatically separate it by space rather than by clicking enter. So yeah, that is probably a better way. Thanks for the help, Gobind. And I'll just continue on with the slideshow then. So let's talk about lists. So as I mentioned earlier, lists are kind of like a container, or specifically in Python, they're called a data structure. And the great part about lists is that they have a lot of functions that are already built in. So if you guys know C++, if you create an array, there's no functions for it, unless you actually use a standard array, which is a templated class. However, in Python, lists have multiple functions that can be used along with them. Let me just show you a few. So, first of all, how can we make a list? We can make a list by just using two square brackets. This is an empty list, right? Now, one way of adding things to this list is we can use a function called list.append. And let's say we want to append 1, right? Let's say if we print list. When we print it, we get the value 1. However, one thing to note for lists is that they're not type dependent and they're mutable. Unlike arrays in C++, they don't have to be of a fixed size. The size can change, and also whatever type you put in it doesn't matter. So, let's say we put a string this time. Google DSC club. And now if you run it, see the list now has two objects. One is of type integer and one is of type string. So there's a few things that you can do in Python with lists. You can add lists together. You can extend a list with another list by using the extend keyword or the plus symbol. So right here we have list 1 where it's 1, 2, 3 and list 2 equals 9, 8, 7. We can create a new list which is the addition of list 1 and list 2. Or we could use the plus equals operator on list 1 where it says that list 1 equals list 1 plus list 2. And both of these would just output the result 1, 2, 3, 9, 8, 7. What it would do is it would just append all of these numbers to the back of this first list. Or in this case, it would append all of these numbers into this new list. And as I just mentioned earlier, you can append an item to a list or add an item to a list. So right here, this list has apple, banana, orange. Now the last index would just be pair after this. And similar to other programming languages, Python also starts at index 0. So if we want to access these elements, we can say letters of 0 and that would give us A. Letters of -1 would give us C because it's 1 from the right. Letters of 1 would give us B. So in this case, if we were to print letters of -1, we should get Google DSC Club. If we were to print letters of 1, we should also get Google DSC Club because there's only 2 things in the list. But if we were to print letters of list of 0, we now get the value 1. And let's just make another list. List 2. And let's just give it a few values. Let's say it has 2, 3, say John, let's say code, whatever. And then we could say that we're going to say list 2 plus equals list 1. So, it's just list. So when we print, and let's use a range-based for loop to print this. Let's say for, say val in list 2, print val. So it would print whatever is in list 2 first, 2, 3, John code, and then it would add whatever is in list 1 after list 2, so 1 and Google DSC Club. And one more thing that's very useful in Python is called list slicing. You're going to actually break up the list into like 2 separate lists or just cut it off. So using the list index and the colon symbol, you can slice up a list, and it's exactly what it sounds like. Slicing, like slicing a cake, you're cutting up a cake, you're cutting up the list. You only get a portion that you want. So the lower bound is actually included, but the upper bound is not. So right here, we have letters, and it consists of A, B, C, D. We're slicing it using 1:3. So 1 is the lower bound, so 0, 1, so it should contain 1. And then it should go up to the third index, but not include the third index. So 1, 2, 3, but it will not include this one. So the only 2 values it should include is B and C. And we can see that is the result. We can actually do that right here. Using list 2. We know that list 2 are these values, right? If we wanted to just print from John to 1, we could do it like this. We could say list 2. And we could go, John is at index 0, 1, 2. So 2. And go to 1, so 2, 3, 4, 5. Because we want to include 1 more than our last spot. And then we can print list 2. Huh? Wait a second. Oh, no. You have to print it like this. Sorry. Yeah, so this actually doesn't modify the list, but it gives you something that you want. So if I print list 2 still contains all of these values. However, if I want to only check these values, I have to print out the slicing of the list itself. Or what I can do is I can say list3 equals list2 slice2.5. And then right here, if I print list3, yep, there it gives us John Coden 1. Yeah. So the slicing actually doesn't modify the list itself, but it returns a list, or yeah, it returns a list consisting of whichever values you wish to get using slicing. And here are some useful built-in functions. We already covered the range function where there's a start and a step. So as we see right here for I in range, starts at 0, 6 ends at 0, goes down by -2, so it just prints 6, 4, 2. Wouldn't print 0 because it doesn't include the upper bound. And we also have a rand function. For the random function, we would have to import the library random. So just as in C++, you can click include. In Python, you can write import. So we would import the random module, and we would use the random integer function. And the rand int, it includes all the values, so it could be from 2 to 5. And since it's rand int, it will only be integers. So let's just take a look how to do that. So up here, we could say import random, and then n equals random dot rand int, and we could just say like, yeah, 2 to 5. And what we can do is we can append into list 1. So then, wait, let's print it first. So we can see we get a random value of 2, and then we can just append it. It's the first list, and then if we print list, yep, we should have any random value at the end. So that's just how you can use the random function. There's obviously a lot of other ways and other functions in the random module, but this is just the most basic one. And round, as we talked about earlier, Kenta, that rounding, it just does a regular mathematical round. So like 3.1 would become 3, 4.5 would become 5, 5.8 would become 6. And for this one, you don't have to import any library. And same thing with absolute value. So you could just use ABS of -4.6 and it would return you 4.6. So, modules. So as we just discussed about the random module, you actually have to import modules in Python. So there's a variety of modules. Like for data science, you could be using pandas, numpy, anaconda, or different modules. For this one, we can use random to get random numbers. In the future modules that we'll be using for the snake game, for example, we will be importing the turtle module. So some modules are already pre-installed with Python, like random, right? All you have to do is click import random. Other modules, you actually have to install the files, and you can install them from pyp.org. And you can just search them up, and they're basically like APIs. You just install them and you import them. Aliasing, you can use the AS keyboard or AS keyword to give your module a different name. So if you don't want to keep writing random.randint, you could just say import random as R. So instead of writing random every time, you could write R. Otherwise, if you don't even want to do that, you could just specifically import one function. So from the random module, I can just import randint. So then I can just click n equals randint. I don't even have to write r.randint. However, note that if you do this, you can only access the randint function. You don't have access to the other functions. But it's very useful because the less things you import, the faster your code will run. Because what Python does is when you import a library, it includes all the code for that library at the top of your program. And another thing is you can just import everything. So from random import a star, and what the asterisk does is it just imports everything from the library. However, you should be careful because this isn't that readable. Like if we take this example, if we take this list for example, we have a list with values 1, 2, 3, and we call the function choice parentheses list. But does choice tell you what type of choice you're making? Is there a specific order? Like how are you trying to choose it? But if you wrote random.choice, now when someone is reading your code, they can realize, oh, it's just randomly picking one element from this list. So readability is key. Now, let's go over some classes and objects. So how can you create a class in Python? First of all, you can just use the class keyword and write your class name followed by a colon. There is no need to make anything public or private because it automatically does everything for you. And in Python, class names are Pascal cased, so you should not use any underscores. And also, it's just common coding convention to make the first letter of your class uppercase. So, creating an object from a class. Let's say we have a class called car. And one more thing, if you don't want to write anything inside your class, you should write the keyword pass. That way, the compiler doesn't give you errors. So here we have a class called car, and we want to make a car from that. So we could just write my Toyota equals car, and we write 2 parentheses. That lets us make objects of this class. And what classes and objects inherently are classes are a data type of its own. When you're creating a class, you're essentially like creating your own data type. A class has its own attributes, functions, variables, and when you create an object of it, that object has everything. So you can think of a class as like a blueprint, and then an object as like the prototype of that blueprint. So class methods. Class methods are basically just like the functions of the class. So this class has a function called drive. And what this function does is that it just prints move. So when you have an object called myHonda, and myHonda is an object of car, when you do myHonda.drive, it should just print move. And then another thing is that classes can also have variables. So, like if we create a object car1 from the car2 from the car class, if we print car1.color, it should just print black. So, one more thing about classes and objects, this is the very most important thing, is that each class should have a constructor. And the constructor in Python is used by the init method, or it stands for initializer, or initialize. So you would have to do define space 2 underscores init space 2 underscores, and then you'd write self. In other languages such as Java and C++, the keyword for self would be this. However, in Python we use the keyword self, meaning that you always have any variables directly related to your own class. So every time you make a new object, the init method is always called, and objects are created from this class. So each class can have certain properties, and those can be like variables of the class, for example. So right here, let's say when we have this class car, we want to initialize it with a name. So we would say self.name equals Jimmy. And what it does is when you create this car, it will set this car's name to just Jimmy. So class inheritance. This is one very important aspect of computer science as a whole. what inheritance does is that, let's say you have two classes, a parent class and a subclass, or a child class. You as a child, you inherit genes from your parents, correct? You're a mixture of both of your parents. Similarly, in Python, the child will have all the functions of a parent. However, a parent cannot have any of the functions of a child. So right here, we can see that we have a class called animal, and the animal has a function called breathe. And this function breathe just prints breathing. However, the class fish, it inherits the animal. You can make it inherit the animal by actually writing animal in parentheses next to fish. And then this function breathe inside fish also has its own stuff. So when you inherit animal from when you inherit animal, the animal class in fish, animal already has the function breathe, right? So if you call fish.breathe, what will it do? It will just print breathing. However, what if we want to change it? What if we don't want the fish to be breathing? Or like, that's a bad way to say it, but what if we want the fish to do other things besides just print breathing? Right? So, we can also add to it. So, first of all, if we have this function called breathe, right? We can use the super keyword, and what the super keyword does is it lets us access our the class you're inheriting from. So what it first does is super.breathe, it will print out breathing, right? Because the parent class does breathing. And then we're a fish, so we want to breathe underwater, so we can print underwater. So if Nemo is a fish and we print breathe, it would print breathing underwater. However, if we had an animal called a cow and we had, let's say, cow equals animal, and we did cow.breathe, it would just print breathing. Why don't we just try it out real quick? So let's create a class. Let's call it animal. And then we should define an initializer. Let's give the animal a name. And then let's give the animal a type. And then let's give it a few variables. So let's say self.name equals name. And then self.type equals type. Let's also create a function called let's just say breathing. So what this function does is it just prints that the animal's breathing. However, let's say we have a class called let's say dog, for example. And it inherits from the animal class. So what we can do is, first of all, we have to have our initializer. We include self. We want it to have a name. We want it to have a type. And since it's a dog, we want it to have a specific breed. So what we can do is we can have it, first of all, so we don't have to rewrite the stuff, we can call super, and then, yeah, we can call super, and then we can call it from init, and we'll just pass in the name, type, and we also have something called self.breed, and then this will just equal breed. So let's also override this breeding function that we have. So let's say define breed. So we could do super dot breathing, and we could also do print woof. So now, if we were to create two objects, let's say we have an animal. Let's say we could just give it a name. Let's say John. Let's say his name is John, right? So let's say animal John, and let's say his type. Let's say he's a deer, and then let's say we have a dog. So my dog's name is Nico, so I'll call him Nico, and the dog has um the name Nico. He's a dog, and let's say the breed. So Nico is a Maltipoo. So then let's call John dot breathing, and then Nico dot breathing, and let's just run it. Oh, line 20. Oh, there it is. Breathing takes. Oh, there it is. Okay, I know what the issue is. So you have to do this. Yes. Oh, we have to pass in self. Huh, why is not printing woof? Super dot breathing. Hmm? Oh, yes. That's why. Sorry. Oh, wait. No, the mistake I made was I have to change this to breathing so I can override it. Yes. Sorry, guys. This doesn't need to be here. So yes, if we run it now, so the first one is breathing and the second one is breathing and woof. So yeah, that's just like a basic introduction of classes inheritance, how to make classes objects, and some basics of overriding. So I think that's about it for the workshop. If anyone has any questions, I'll be happy to answer them. And in the presentation, I've linked the console calculator and a preview of the snake game. If you guys want to take a look at the snake game, which we will be making. Oh, yes, I can just send a link of that REPL right now. Copy, and then I'll link it right here. Yeah, and the snake game that will be. Hmm? Oh, Oh no, I did it all in one file. Yeah. I didn't make it in separate files. I did it all in one. Yeah. So the snake game that we'll be coding. Um, it's as you can see, this will be the third class, and it's just a basic snake game. Okay, this is actually really hard. Yeah. So every time it increases the score, and increases the length of the snake. Yeah, so if you guys want to learn how to make snake, please attend the next two workshops as well. And yeah, that's about it. If anyone has any other questions. Yeah. Yes, yes. If you don't have this, it will still work, because if you call, let's say I delete this, right? It would call the super. Because remember that dog is of class animal, right? Dog is an animal, correct? So even though all of this code, you don't see it under the animal class, it still has it. It's not that it doesn't have it. Just because you don't see it doesn't mean that it doesn't have it. You could still call all the functions in the parent class, in the child class. But in this case, we wanted to make it so that breathing also said the word woof after it, which is why I created breathing again, and I called the previous one the super function, and wrote print woof after it. If I didn't do that, let's say I didn't do. So originally I had it like this. If I do this, then it prints breathing and then breathing woof. If I take out this line, right, then it will no longer print breathing. Because what's happening is that it's just replacing the function with whatever is here. So if I want to include what the parent class function would be, then I would have to write super and call that function. So the super keyword is how you access things in the parent class, and the self keyword is how you access things in the current class. And keep in mind, whenever you make a new function inside a class, you must always use the self keyword. Otherwise, as you can see, we got the 2 errors before, and that was due to not writing self. And you have to write self because how it works is that in Python, every class is inheriting the object class. But you don't need to write it. You don't manually need to write object inside of here. It's just doing it for you because it's already a templated library and it includes functions like the initializer function. However, using the self keyword tells the compiler that each function is using this specific variable. Because let's say right here, for example, right? We're taking a few arguments. We're taking the parameter name, type, breathe, right? But what if we remove self? How would it know what is the difference between this name and this name? It wouldn't, which is why we use the keyword self. And the keyword self tells us that self.name is the variable name and we're assigning it whatever the value inputted in this name is. Which is why the self keyword is so important in Python. Yeah, that's about it. Any other questions? No problem, guys. Thanks for attending my workshop as well. And I plan to host 2 more workshops leading up to building that snake game. So if you guys just want to try out the snake game or play it, you guys can just open the link at the end of the presentation and it should take you to a REPL and you can just run it. And next workshop, I plan to teach like the logic behind the snake game and how to actually make graphical user interface. So just kind of like a mini homework assignment, you guys can start thinking about the logic and then maybe just type it in. Let's say, do we have a channel for that? How about in side projects, you guys can just type about it and then I'll take a look at it and then let you guys know how I think your logic is regarding the snake game. Oh, cool. Okay, so Kenta will make a workshops projects channel and then you guys can type in there. Yeah, so that should be about it. Thank you for attending my workshop once again, and then